is what my colleague Graham and I did with Google BigQuery. So Google BigQuery, in a very short nutshell, it's a big data store. It's very, very fast. You basically import CSV and JSON, and then with that CSV and JSON, it goes and imports it into your traditional looking DBMS type tables. And then you, Dean alluded to this before, you just use normal SQL queries and you can do groups and summations and everything else that you're used to. There's a few tiny limitations in there, but most of the stuff we've been able to work around. There's a few nice syntax shortcuts as well. There's also an API that we use to integrate with all the apps. So I'll show you a demo of a JavaScript app that talks to BigQuery directly and retrieves the data, feeds it in. And it's basically a infrastructure as a service. So there's no setup fees, but you do pay as you go, and I'll show you the fees and stuff in that too. So this is a mishmashed query, but basically you're just selecting all your different columns as you normally would. See if I've got a mouse pointer. I don't have a mouse pointer here, but basically we're stepping through. Line 3 is where we're doing, there's day of the week functions, there's functions to convert from Unix timestamps, there's functions to, I haven't seen this in any other relational database, but to go from host names and IP addresses and back and forth. There's the really cool one, line 5, if you can see it. It's doing a regular expression matching. So where we use that is where we've got actually a field that's an aggregate, where it's like all these different fields, AB equals 3, and a whole bunch of different things all in one field. And with that, what we do is we basically, it can, on the fly, look at those contents of those fields, and they can basically be extracted into their own fields as well. So then we can then query on those and aggregate just on those fields. And then towards the end, so rather line 7, you just do a count star. So it's one of the first SQLs you do in uni, right? Like you just do your select thing, count star. The other neat thing, towards the bottom, you've got this group each by, but unlike Oracle, you don't have to repeat the whole expression, which is kind of nice. So just whatever your aliased column is. So if I had this big if regex match and I call it flag for counting, then I can just go group each by flag for counting. I don't have to repeat myself over again. And then, let's see, yeah, you left out a join is kind of normal. You're used to that. It's otherwise quite similar. The only restriction we've encountered is that you can only have one union or one left outer join per query, but you can nest those queries. So it's a bit annoying. Like it's like a really hacky, very early SQL where you don't know how to join so well, or you don't know how to do unions so well. So everything's just stacked on it, like a query and a query and a query. Well, this gives me the result. Then I'll just wrap that in a from statement, put that in my from statement, wrap that up again. So despite all that, we're told that that's coming in a future version. You can work around it. So that was the only limitation. But for the speed that we got, 2 billion rows in 20 to 25 seconds that it iterated through, it's phenomenal. I don't want to go back to an Oracle database ever again, because it's just so fast. And you know, for a normal query, 2 million rows in 2 to 5 seconds, and that's the uncached version. And then it caches that same query for 24 hours, so then you get it back instantly.
Yeah, it's worth mentioning as well that that table that we were querying with 2 billion rows of it was somewhere between 3/4 of a terabyte to a terabyte. Yeah. We're getting those results in about 20-25 seconds.
So that's just, so that 2 billion row table, is that with a join or without a join on another table?
That's raw data.
Just raw. It's raw. But even, I don't know, I think the way it just seems to pull these guys together, so the joins don't, I mean, they're just like whatever your Cartesian product, and you're having extra rows to go through, but you're not, we haven't seen anything super bad. The only thing that we've seen is doing a group, like trying to use this for deduping, and then we've hit its limits. Probably worth mentioning that the Google engineers on BigQuery are on Stack Overflow, so there's a Stack Overflow channel, and they've been pretty good about responding to questions within the same period. So when we had this massive, there's no what's the I think there's a distinct keyword in Oracle and most RDBMS.
Yeah, you don't get that with BigQuery.
Yeah, so they don't get that, but they're just like, well, a distinct is a group by, like you just do all your columns in group by, but then that's where it starts doing some really, that's where you start pushing it to its limit. So grouping, trying to a distinct 1 terabyte big table is going to push it, but you know, most of the time you're not using it for that. So,
is there any feedback on what sort of amount of hardware is involved in delivering this to you?
as far as we know, they basically it's in Google's cloud data centers. They do all the MapReduce stuff in the background. So there's a project that they started with called
Dremel.
Yeah, Dremel. And that was a white paper that 2 Google engineers released, and then from that product, that was basically doing what BigQuery is now. So they productized that into BigQuery. And the whole idea is just basically a facade for that same kind of fork join, splitting off your work into different servers. And because Google's got so many servers that they can, just throws your query out to everything.
Yeah, but I mean, this is a lot better than the performance you can get from a tired old laptop on the shelf sort of thing.
That's right. Yeah.
So there's some serious disks or solid state drive stacks and clusters and
Yeah, I'd say
all
so.
of this sort of stuff behind the curve there. So just wondering if they gave you that sort of metric.
Yeah, I mean, I think with anything that they do, it's just all, like, this is the benefit of fork join. And so this is where you take your problem and you split it up, and then because it's just basically how many servers then you've got. So then it potentially doesn't even matter what hardware you've got. But I'm sure that they probably, I can't speak for them, but I'm sure that they've got all the fancy stuff in their data centers and stuff there.
What's the speed up to Oracle? What billion rows?
Speed of Oracle? Oh, I don't know. I don't want to go back. It's too.
It's Oracle, right?
Well, what do we use a reporting tool. Just sort of jump back before because that's kind of distracting. But the speed of it's to go over the same amount of data. So this client's database was something like 17 million rows, and to do any kind of similar query where we're looking at particular fields, and they're fields like atomic fields, like one column represents one thing. There's no regex magic or anything, but it takes a long time to aggregate that stuff up. And then the tool tries to employ some caching or whatever, but it's still, you're waiting like a 3-minute turnaround, like sort of most of the users are doing. And then you've got to start indexing that manually yourself, whereas with this, you don't do any indexing. It's just there.
Was there a significant time involved in loading the data?
Yeah, so that's a bit slower. So I'll probably talk about that in a moment. Inserting data is free, but you do there's a time lapse. So maybe what we're seeing 10 minutes.
Yeah. So a day's worth of data was about 3 million rows. That took about 20 minutes to get in.
And you were loading those in bulk at the end of the day?
Yeah, batch loading.
Yeah.
Might be the reason because they create 3 copies of the data. Because in the demo they create 3 replication of the same data.
Right. Well, yeah, I don't know about that, but what we were doing was simply pulling files from the cloud, so Google Cloud Storage, which are just raw CSV files. Each file was about 1.5 gig, and we were pulling it in by the month, which was about 72. So it was about 3/4 of a terabyte, and that took about an hour to pull that data in.
Yeah.
What's going on behind the scenes, I don't know.
It's probably, even though with small tables, like we've got something maybe 1,000 rows, and even then there's a delay. It's not like a normal database where you can get this quick.
So you couldn't load it in real time, correct?
No, they offer a streaming insert option. It's currently in beta.
It's a little bit buggy. I played with it. So you do your streaming inserts, which is marketed as being real time, and you stream these inserts into the database table or into a table, and then you query that data, and it's actually not available for like 5 seconds or something. So they're still working on that.
Alright, so if you know this scene from Breaking Bad, this guy's taking a nap on a big pile of money. If you probably went loose on, I'd love to work for Google and be let loose on Dremel, because then you could just go nuts. But it's very quick to run up the bill. So we probably in our first month while we were doing our discovery phase, we probably spent about $1,000 on stuff, and I'll talk about how that is made up. So you can see on the screen, $80 per terabyte. It seems to be only billed at the end of the month though, so you could probably go in on day 30 and delete all your data, and it'd probably bill you just for a small amount. Don't quote me on that, but that's what we've noticed. This looks a bit weird, but then this is where you're getting your money taken from you, is $35 a terabyte for an interactive query, which basically means as fast as BigQuery can give it to you. And then if you want to save some money, there's a batch mode, which is only $20 a terabyte, and then you wait half an hour for that data to come back. So it's literally, you see it go up to 1800 seconds, and then the equivalent 2 minutes or whatever it took to do the query. So it's a good way for batch jobs, obviously, and saving a whole bunch of money that way. The other thing worth noting is the, let's see, $25 a batch. They do have extra plans. So if you're going to say do above 100 terabytes, then your interactive cost gets cheaper. You can buy a package up front, and then the cost per terabyte goes down. And there's the link for the pricing at the bottom as well. And so every time you go to do a big query, you get a little validation message. First tells you if the query doesn't work, you don't get billed for it, thank God. If it's syntactically correct, you'll get this little pop-up after 5 seconds saying it will use 822 gig or whatever it's going to be. So this was the table size was 822 gigs. So I assumed that what we were doing at the time was doing a count of something in the table and pulling together a whole bunch of rows. I think it's a bit over 2 billion rows that we were doing with this query. So yeah, across the whole data set there, and so you get that little more message, but you do have to be diligent. When you click on this enable options button, you do get the options to switch on batch mode or interactive mode, but you just got to keep an eye on it. Sometimes you just press the button and go, oh, we just used up $30, oops, so just it takes a bit of getting used to, I think, but nobody's perfect. So, and then
you also can't abandon a query. So when you issue it to Google BigQuery, there's a button which actually says abandon. But when you press abandon, it says, yeah, we'll abandon it, but we're still going to charge you. So just be careful if you're playing with it.
So the only time that button's good is if you really know it's wrong, and you're not going to get the result anyway that you want.
It's a question from there.
Yeah.
When you say you build a terabyte or whatever, if you build $30 per terabyte or whatever of data, is that per terabyte of data that's actually processed in the query, or just data that's returned? Processed. So if you had a lot of data, a select aster is costly.
Yeah. The way it works, they do it based on the columns. So I think I mentioned that before, but the more columns that you have in your SQL, then that adds. So if you selected one column as opposed to from your 20 column table, that'd be far cheaper than doing multiple, I suppose. Yeah. And then once you start joining to other tables, then of course you're adding more columns, right? So then that's where the cost increases.
What's the particular user case?
What can we tell you about the user case? There's lots and lots of data, and it's quite sensitive, but they want to. It's aggregating a lot of results. So I can't really speak specifically on our client stuff, but what I could talk about was, let's see, do we know any case studies? Amazon were in there.
Yeah, there's a few in there. I can't recall off the top of my head.
Yeah, there's a few big name companies. I can't remember, but I mean, for me, it's the use case is, hey, I don't want to learn Hadoop. I already know how to do SQL. I've got a whole bunch of CSV files which I need to import and process this stuff.
Now for a website, right? It's going to be real-time website.
Okay. Well, I'll go to talk about this. I mean, if you wanted to do it for a real-time website, you just have to be concerned about the pricing of it. And so we had to basically build, for our client, build a pricing table. And what we ended up doing was we built a whole set of summary tables so that they weren't querying with, so the most common things that they were doing, they were just, it was like a mini ETL in a way. It was just the fixed data set, right, of what they're doing. So we kind of cheated a little bit, but it's still going to the, we're still using this JavaScript API, and there's also a Java API which we're using for batch jobs, where we're hitting, we built a web page which hits the BigQuery directly with the SQL and gets the results back and graphs it. And that's exactly what I just talked through there. So the only limitations, you just have to, like Dee mentioned security before, and so we're running this in the LAN, so we don't have to put it out on the internet, and we know who's talking to Google BigQuery. We're also tidying that down so there's less points that are actually talking to BigQuery directly. So it's just something that you'll have to keep in mind in your architecture, but it's doable. And I've got a demo of it. So it's all sensitive customer data. That's why you see all the grayed out stuff. But let's go through. So we've got a pie chart of male and female. So what we did is we plugged this into Google visualization, so Google Graphs plugin, which used to be just images, and now it's all SVGs and other fancy stuff. So you get filters, if I can click on them properly, and we just use Bootstrap to properly recognise the UI. But you get for free that edit chart thing, so you can, that's kind of nice. Scroll down, and you can get hover over the graphs, so you get tooltip pop-ups and more filters as well. The only nutty thing about this library is that Google decide when it's nighttime in the States, they decide to do upgrades, and so sometimes 3 o'clock in the afternoon for us, it's like the library gets a 500 error, and the client comes up to you and goes, why there's no more graphs? And we look and, oh yeah, no, we can't talk to the API anymore. So that's kind of sucky. If you needed something more reliable, maybe D3 or whatever, but for us, this was a quick way to iterate, so it was a very easy API for graphs, and so that was why it was really cool to do that. Yeah, you get a map of Australia, you get a few other ones, and you saw you could edit the charts there as well. So, yeah, as I said, I'm quite in love with it. I don't want to go back to anything else. The insert performance isn't, so it's if you're depending on that kind of stuff. But there are people who are using it, say, for gaming platforms, and they're using the streaming API to put that stuff in. If you know SQL, you're pretty much set to go. You just have to watch the costs. You do get a console where you can log into and they do a daily update, so you know where you're running for the month. And so my colleague Graham blogged on this, so you can go to blog.shinetech and look for reeling in big data using Google BigQuery.
Big data using Google's BigQuery.
Yeah, go read more about it. And so yes, we don't. I mean, the crazy thing, like the client initially wanted, some sort of thing like JReport where you drag and drop, and you can imagine there's a whole lot of stuff. So we built from scratch a little bit of reinventing the wheel, a little bit of discovery of give the client a UI where they can at least select and filter a few things. But there's a lot of effort from then making that drag and drop and doing that yourself. So yeah, what we may end up doing with this client is that they may end up pulling it into something else as well. But we'll see. There is a few JDBC drivers for BigQuery. They're all still all alpha-y and beta-y and stuff like that though. So if you do have another reporting tool that does take a JDBC connection, then you can give that a shot. But I don't know, I don't want to spend the sleepless nights on this, and this was quite a fun project to work on. So yeah, any other questions?
You mentioned before the occasional query, you still pay every time you fetch it in.
No, that's a free one. So,
no, so
yeah.
So you only pay once per 24 hours.
Exactly, your cost for 24 hours.
Yeah, that's right.
Colin, you mentioned some of the data is sensitive. I'm just wondering what Google
do about privacy of that data? We've got big customers ourselves with very sensitive data. We'd be in the newspapers if any of that leaked out, and I'm wondering what Google do to guarantee that they or anyone else doesn't get at the data you're inserting.
Yes, look. What are you doing? I can't. I mean, it's the same thing with any cloud thing, right? So
yes,
you know, it's going to be, hey, it's hosted in the States. The NSA or whoever else can walk into the data center with a warrant and take it. So yeah, while it's still you don't know where it's hosted actually. So you know, it's odd. Your query sent out to millions of different servers.
So the goal is to actually encrypt or denature particular fields that are sensitive, I guess.
I suppose so. I mean, for us.
Did you push anonymized data up there, or did you push just sort of everything?
Well, yeah, it's not quite. The data we've got is okay in that respect, mostly. So you've got. Just trying to think what it's not. There's nothing to say. You know, Daniel Falata.
There's no
does
personal
this.
identifiable information.
Yeah.
Right.
Yeah. So yeah, I suppose you've got to keep that
What?
in mind.
So why did you fuzzy it out then on the slides?
Yes. So we fuzzied it out for the clients because it's client data, but yeah, we could have prepared a few other demos, but because this is what we had, and we just wanted to show it now for this topic because we thought it was related. Any other questions?
Is there any guarantee on performance? Because all of this service looks like for performance per point of view, and do Google guarantee something? So 5 seconds for billion rows or something like this.
There's nothing stated anywhere, but
So there is no SLA. I'm
No.
using you, I'm paying you data. What the lowest performance I'm going to assume?
Yeah, I don't know. Like maybe you just need to be a big enough customer, and then they'll give you an account manager that you can complain to, who'll then escalate up for you.
Because with Amazon, there is such thing. Like when you're working with Amazon Cloud, there is SLA about performance, and
Yeah.
you can start to ask questions if they are not providing this.
Sure.
I just wondering whether Google
That's a
should
good
be
point.
the same voice.
So last year I went, as part of Java 1, I went to Google, and they did a whole big thing about Google Cloud. And so this BigQuery is just a small slice of all their cloud offerings. So I would say in that there is SLAs like any other cloud provider around that kind of stuff. I don't know what they are off the top of my head, but I would say they're decent enough to look at. And their whole big thing was that they're trying to go back to reworking their products to make them more like VPS, or like basically like a server that you run up rather than this locked down environment that you can only run Java and Python in. So they're basically trying to catch up to the rest of the market's doing, and I'll try to be competitive in that regard, including SLA, which I think would be important.
For every enterprise customer.
Yeah, I'm just trying to think, have we had any issues? There was an issue we had with the JavaScript API. So that the API is in beta. They've got a Python and Java API, which are fully baked and production ready. There was one instance where the JavaScript API went down for about 8 hours when we were first doing that, but all the other APIs were fine, and the web interface was fine. So it was just a thing of, yes, we stuffed up, and that won't happen again. So yeah, that was a bit of a learning experience to use that. I think to do it around the second time, definitely put talking to BigQuery on a Java or a Python app, something that's a bit more supported, a bit more robust. Then other than that, I don't think we've seen any outages with the actual BigQuery.
never with BigQuery itself. Just the obvious.
What was the daily maintenance one you mentioned before? You got the 500 errors?
So there was two things: the Charts API, so just Google Charts.
Right, it's a particular API.
Yeah,
Yeah.
that was it. That one. Yeah.
While looking for these options, like going to the Google BigQuery, so did you guys ever thought of indexing these documents in, something like Solr Search, and then digging out all those dashboards?
Do focus on running out of solutions.
Well, for us, we were lucky because our data was already in the cloud already. So it was actually, we didn't want to pull it down to then just do it in Solr. And then potentially we could have run up another instance and done it in the cloud as well. But everything was in the right place to make it easy for us to bring in this data. So it just made it more attractive. And generally, like we've got a lot of Amazon projects that we have, and so normally we'd probably jump onto an Amazon thing first. I mean, I can't say that's a big generalisation, right? But that's probably what we would have done.
Because I know some of the companies, we have built such kind of things by using the solar technology, by indexing the documents, and then on top of that, we have created very nice visual kind of charts to represent the data, which are higher management. And,
Yeah.
you know, you can drill down to any level by using those functions which are out of box from the solar itself.
Sure.
So people are,
Yeah. Yeah.
and it's very fast.
Yeah.
No compromisation.
Yeah. I know we've had a talk on solar before. I've certainly used it in the past, and it's great. Like, I mean, the speed at which you get stuff back, it solves a lot of bottlenecks, really. So yeah, definitely. All right, guys. Well, thank you very much. Thanks for coming. Do we have any pizzas left? No. Yeah.